Assalamu alaikum students. Before going to our educational topic, please subscribe my channel Muntzir Mehdi Science TV on YouTube. Press the like button and share this lecture to your friends and classmates who have no access to it to add in their science education. And those students that are preparing privately can benefit from our channel very effectively. Let's come back to our topic. Today we will know about X-rays. That what are X-rays, what is the diffraction pattern that is achieved by these X-rays, and in which example we will use X-ray to derive an equation. So let's start with what are X-rays. The answer is that X-rays are high frequency electromagnetic radiations that are emitted only that time when fast moving electrons hit to the metal surface. When these electrons, such as some of these electrons, left their positions and strike to the metal surface, then this metal surface emits some special types of rays that are known as X-rays. These X-rays are of high frequency electromagnetic radiations. It is notable point that the inner electrons of the metal atom, especially from n is equal to 1, meaning that those electrons that are present in the first orbital of a metal atom. First orbital, such as it is the nucleus of a metal atom. Around this nucleus there is present first shell that is known as K shell. In this first shell there is always present two electrons. So when these first electrons of the metal atoms are disturbed due to the jumping of electrons from one orbital to other orbital, in other words we can say that this jumping of electrons occurs due to disturbance of electrons, because when these electrons are disturbed, so due to this disturbance the electrons moves from one level to the next energy level. This next energy level can be M energy level, L energy level, or N energy level. So due to this movement, due to this jumping, the photons of light are emitted that are known as X-rays. These X-rays are high frequency electromagnetic radiations. The wavelength and energies of the X-rays depends upon the nature of the metal. Actually, alpha 1 and alpha 2 are the lines of the X-rays due to the jumping of electrons, due to the exciting of electrons from L energy level to K energy level. L shows second energy level, whereas K shows first energy level, that has shown in this diagram. We can also understand it with the help of a diagram. Suppose it is L shell of a metallic atom. Inner to this L shell there is present K shell. K shell has maximum number of electrons that are 2, whereas L shell has maximum number of electrons 8. But suppose there are present only 4 electrons. It is theoretical distribution of electrons. But suppose in the K shell there is present only 1 electron instead of 2. So when jumping of electrons from L shell to K shell occurs, then it causes the production of alpha 1 and alpha 2 X-ray lines, whereas beta lines of X-rays are produced when jumping of electrons, exciting of electrons takes place from M shell towards the K shell. So we can say that by the movement of electrons from L shell to K shell, alpha 1 and alpha 2 X-ray lines are produced, whereas by the movement of M shell from K shell, beta X-ray lines are produced. For the separation of beta lines from alpha lines, beta filters are used. Alpha 1 and alpha 2 are so close to each other in wavelengths that they are looked to be monochromatic. Their resolution is difficult and they can be used for the crystal study jointly. We will also see some examples of metallic atoms to understand the X-rays from various metals, their wavelengths and the beta filters. Beta filters can separate the wavelengths of lower wavelengths so that alpha lines may be used in X-ray crystallography. Suppose our target metal is chromium. The wavelength of its alpha 1 line will be 2.289 angstrom. The wavelength of alpha 2 line will be 2.293 angstrom. Similarly, the wavelength of beta line will be 2.085. Its beta filter will be vanadium that has the thickness of 0.016 millimeter. Similarly, Similarly, target metal is cobalt. Its alpha 1 line has the wavelength of 1.789 angstrom. Alpha 2 line has 1.973 angstrom. Its beta line has the wavelength of 1.621 angstrom. Similarly, beta filter of cobalt will be ferrous with thickness of 0.018 millimeter. So these are some examples of metal target that have the wavelength of alpha lines, beta lines, and their beta filters. Next we will see the diffraction of X-rays. Usually X-ray tubes are used which emits electromagnetic radiations with wavelength of about atomic dimensions. In most of the cases, a typical atom might behave like a hard sphere of about 2 angstrom diameter. The characteristic X-rays that are achieved from copper metal may be used for X-ray crystallography. The wavelength of such rays are 1.5418 angstrom. When these X-rays pass through a crystal, then they are diffracted to different planes. They form an interference pattern like that of visible light, which is diffracted by a grating. The spacing in the gratings are comparable to its wavelength. X-rays, which are electromagnetic radiations, electric and magnetic fields, are propagating perpendicular to each other. They are also perpendicular to the direction of propagation. The scattering of X-rays is due to the interaction between the electric fields of X-rays that take place with the negatively charged electrons in the crystal structure. This scattering power of an atom is proportional to the atomic number or the number of electrons in the atom. The crystal acts as three-dimensional diffraction grating towards X-rays. So a diffraction pattern is obtained when X-rays pass through the crystals. So students, there are many different types of fields, techniques and methods during which X-rays are used. The utilizing of X-rays in these fields, techniques and methods causes to understand these phenomena thoroughly. For example, X-rays are used to derive Bragg's equation, Bragg's method of X-ray analysis, powder method and Lois method. So there are many different types of techniques, methods and equations during which X-rays are used as an important fundamental thing. So we can say that X-ray has so much importance in science experiments in different fields of life. So students, it was an introductory video about X-rays. In this video, it has been clearly explained that how X-rays are produced from a metal atom. That was explaining about basic synthesis method of X-rays and how these are hit to a crystal structure. All those examples that are explained here, such as Bragg's equation, Bragg's method of X-ray analysis, powder method, as well as Lois method. If you want to understand them in detail, then you can ask me in comment section. But if you want to understand any other topic about science knowledge, then you can question to me by writing your question in our comment section. And also write for which class, for which standard you want that topic, like for first year, for second year, for 9th, 10th or for BSc. And also from which subject, like from bio, physics, chemistry or from botany or zoology you want that topic. I will try my best to make that topic for you as soon as possible. So make sure to subscribe our channel for further upcoming videos and also make sure to like these videos. At the end, I will advise you, take care of your country, your environment, your surroundings, your parents, your relatives, your brothers, sisters, friends and yourself. Thank you for watching this your video.